Hello and welcome to Lesson 7-1. Today we're going to look at solving systems by graphing. So ultimately we're going to solve systems by graphing. Okay, we're going to find out what a system is, and we're going to look at analyzing special types of systems as well. So first and foremost, a system of linear equations is two or more linear equations that are going to be put together, okay? And by putting together, it means that there's a relationship between them, okay? So a system could look something like what you see here, where we have y equals 3x minus 6 and y equals negative x plus 2. And in this section, in order to solve this system of linear equations, what we're going to have to do is we are going to graph the system on the same coordinate plane, and then we're going to look for things that we notice, and we're going to try to figure out what they mean. So let's go ahead and do that real quick. So the first thing I'm going to do is I'm going to graph y equals 3x minus 6. So I'm going to start out at my y-intercept of negative 6, and I have a slope of a positive 3, so I'm going to go up 3, 1, 2, 3, over to the right 1, up 3, 1, 2, 3, over to the right 1, and I'm going to connect these 2 points. Next, I'm going to graph the equation y equals a negative x plus 2, and I'm going to do that by starting out on my y-intercept of 2, and I'm going to go down 1 and to the right 1, down 1 to the right 1, and I'm going to connect these points then. So now, what I've got is I've got 2 graphs on the same line, or my system of equations is being graphed together, and what I can see is I notice that I have a point of intersection right here at the coordinate point 2, 0. So this coordinate point tells me when these 2 equations are equal, or when they are the same. So we would say that this is a solution. So this is a solution to the system. Okay, and the system right here is the y equals 3x minus 6 and the y equals negative x plus 2. And what a solution is that means I can plug in the x and the y values. So like if I were to plug in 0 for y, I would have 3 times my x, which is 2, minus 6, and this would be a true statement. So I really end up with 0 equals 3 times 2 is 6, 6 minus 6 is 0. So this gives me 0 equals 0, which is correct. Likewise, if I do the same thing down below and I plug a 0 in for y, I have 0 equals, and then I have my x, I have the opposite of my x value, which is 2 plus 2. So negative 2 plus 2 also gives me 0, so that's correct. So that tells me that that is the only point on either one of these graphs that will make both equations true. So as you're going to see in this chapter, there's multiple ways that we can solve a system of linear equations. The first way that we're going to learn, which is what we just did, is to graph the system of linear equations. Okay, and what we're ultimately looking for is we're looking for any point in common to all of the lines, or essentially that point of intersection. That point of intersection is going to be the solution. Okay, so an ordered pair that makes all of the equations true in a system, because we can actually have more than 2 equations, this is what we call the solution of that system of linear equations. So for example 1, it says to solve the system by graphing. And here we're given 2x plus 1 and y equals 3x minus 1. So I'm going to start out this equation, y equals 2x plus 1 will be my blue line. So I'll start out at my y-intercept. I have a positive slope of 2, so I'm going to go up 2 and over to the right 1, and I'm going to connect those points. Likewise, for the second equation, y equals 3x minus 1, I'm going to start out at a negative 1, and here I have a positive slope of 3, so I'm going to go up 3, 1, 2, 3, and to the right 1, 1, 2, 3, and to the right 1, and I'm going to connect these dots now. So here's the graph of y equals 2x plus 1 and y equals 3x minus 1. I do notice that my 2 graphs cross, or they intersect, and they are going to intersect here at the point 2, 5. Now remember, what this means is that the coordinate point 2, 5 is a solution to both y equals 2x plus 1 and the equation y equals 3x minus 1. So you need to write your solution out like this. It does need to be in an ordered pair because it does represent x and y. And it will make both equations true. So keep that part in mind as well. Please take a quick second and try to do this one on your own. For example 2, we're going to graph y equals 3x plus 2. And I'm going to do that in red. So we have 2, 2, negative 2, negative 2. So I'm going to start out at a positive 2, and I'm going to go up 3. So 1, 2, 3 over 1. And I'm going to connect these. Likewise, for the equation y equals 3x minus 2, I'm going to start out at a negative 2, and I'm going to go up 3. So 1, 2, 3 over 2, over 1. And what you'll notice here is that both of these graphs are actually parallel. Now, if you remember from the 6-6 video that we watched in the last unit, you may have noticed that they were going to be parallel from the beginning because both of these equations in slope-intercept form have the same slope. So M1 is going to equal M2, which tells me that these are going to be parallel lines, and they have different y-intercepts. So what we would say for this one then is our solution is going to be none. There's no point between two parallel lines that will cross, okay, because they're parallel, which means they're running side by side. Okay, so these lines will never intersect, which means we will have no solution. Now for example 3, we're going to solve this by graphing, and I would highly suggest that you take the first equation here, 3x plus 4y equals 12, and you write that in slope-intercept form. So when you do that, you get y equals, I'm going to move my 3 over, so that gives me a negative 3x, and then I have to divide it by 4, so I get a negative 3/4 x. And then I have plus 12, but I have to divide that by the 4 with the y, so I'm going to end up with plus 3. So when I go and I graph that, I'm going to start out at 3, and I'm going to go down 3 and over 4, so 1, 2, 3, 4. So I've got my 2 points, I'm going to connect them, and I end up with a graph that looks like this. Now I'm going to do the same thing for this next equation, y equals a negative 3/4 x plus 3. Again, I'm going to start out at a positive 3 for my y-intercept. I'm going to go down 3 and right 4 units, which is going to put me here. And if you notice, when I connect these points, it's going to put me right over top of that same yellow line. So in this case, I just graphed the same line onto each other. So my solution for this one is going to be infinitely many solutions because every single point that falls on this line here is going to be a solution. And there's infinitely many numbers of points on a line. That's why we have infinitely many solutions. So to kind of summarize what we just went through, when you have equations that have different slopes, then we're most likely going to get a point of intersection or one solution, okay, because they will cross. If you have two equations that have the same slope and different y-intercepts, remember that this tells us that we have parallel lines, and with parallel lines, we have no solutions. And then if we end up with two equations that have the same slope and the same y-intercept, kind of as in this case, this tells me that we have infinitely many solutions because it's the same line. So these are the way that you can tell how many solutions you're going to have. You should either have one solution, no solution, or infinitely many. So for example 4, it says, suppose you are testing 2 fertilizers on bamboo plants A and B, which are growing under the exact same conditions. It tells us that plant A is 6 centimeters tall, and it's growing at a rate of 4 centimeters per day. So for plant A, my equation then is going to be y equals, it's starting out at 6 centimeters, and we're adding 4 centimeters per day. So it's going to grow 4 centimeters times the number of days that this plant is allowed to grow. Plant B, on the other hand, says that it is 10 centimeters tall, and it's growing at a rate of 2 centimeters per day. So 2 times the number of days that it's left growing. What we want to do is we want to find out when the plants are the exact same height, and we want to find out how many days it will take. So we want to know is how many days it will take to be the same height. So we're going to start out by graphing. So I'm going to begin by graphing my 2 equations. So for graph A, I'm going to start out at a y-intercept of 6, and I have a slope of 4. So I'm going to be going up 4, so 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. And then what I'm going to do is I'm going to connect these points, and I'm going to do the same thing for graph B. So for graph B, I'm going to start out at 10, and I'm going up 2 and over 1, up 2 and over 1, and I'm going to connect these points. So now what I get is I get a graph that looks something like this. So in order to find out when the 2 bamboo plants are going to be the same height, I have to find that point of intersection. So this point of intersection is going to be the coordinate point 2, 14. Well, X is representing the number of days, so this is number of days, and Y is the height of the, I'm going to put height of the plant. So I can see it's going to take me 2 days to reach a height of 14 centimeters, and this is when both plants will be the same height. So your solution then is going to be 2, 14. Now for example 5, it says you're testing 2 fertilizers on bamboo plants C and D. Plant C is 5 centimeters tall and growing at a rate of 3 centimeters per day, while plant D is 1 centimeter tall and growing at a rate of 4 centimeters per day. We're going to write a system of equations that models the height of each plant as a function of the number of D days. So to do this, I have plant C, and plant C says that it's 5 centimeters tall, and it's growing at a rate of 3 centimeters per day, or 3 times the number of days that it's allowed to grow. And plant D is 1 centimeter tall, and it's growing at a rate of 4 centimeters per day. So again, I'm going to graph both of these, and I'm going to see how many days it takes for them to be the same height and what that height is. So again, I'm going to start out by graphing my y-intercept of 5, and I have a slope of 3. So I'm going to go up 3, so 1, 2, 3, over 1, 1, 2, 3, over 1. Now notice here I did adjust the scale of my y-axis or x-axis just to kind of make it a little bit easier to see. So here's that graph. Now I'm going to go ahead and plot graph D. So I'm going to start out at 1, and I'm going to go up 4. So 1, 2, 3, 4, over 1, 1, 2, 3, 4, over 1. And I'm going to plot these points on a graph real quick. And when we do that, our point of intersection is here at this point, 4, 17. So what that means is it's going to take us 4 days to reach a height of 17 centimeters, and this is where they're going to both be the same. So the coordinate point 417 is my solution. For example 7, it says 2 friends are walking around a quarter-mile track. One person has completed 6 laps before the second one starts. The system below shows the models of our distance and time of the miles that each walker covers as a function of time t in hours. Find the solution of the system by graphing it, and we're going to use increments of 0.5 on our graph, and then we want to know what the solution means in terms of its original situation. So I'm going to go ahead and get my graph set up first. And my equation d of t equals 3t plus 1.5 is going to be represented in the blue. So I'm going to start out at 1.5, and I'm going to go up 3, so that's 1, 2, 3, and over 1. So I'm going to go ahead and connect those 2 points. Then I'm going to do the same thing for the d of t. is equal to 4t. Now really, that's 4t plus 0, so I'm going to start out at 0, 0, and I'm going to go up 4 and over 1, up 4, and I'm going to change it to black over here on my graph. I think that might be easier to see. And then I'm going to connect these points and see where we end up. So when I graph these, my solution point is going to fall right here. Now this right here, if I go down to my x-axis, this is 1.5 and 6 on my y-axis. So this is the solution. So for part A, I have 1.5 and 6. Then for part B, it says, what does the solution mean in terms of the original situation? So ultimately, our t, or our time, equals 1.5 hours, and our y value, or d of t, is going to equal 6. Now this is really our y value, which is distance, so this really equals 6 miles. So what this means is after an hour and a half, both friends have walked 6 miles. Now for example 8, it says, suppose you plan to start taking an aerobics class. Non-members pay $4 per class, while members pay $10, plus they pay an additional $2 per class. Now this case right here is actually a pretty real life scenario, because sometimes if you pay memberships, you get reduced rates on things. But if you're not going to utilize that service very often, sometimes it's just cheaper to pay more money for a 1 or 2 time use as opposed to paying the membership and then paying less money. So what you have to do is you have to figure out which case is going to be the better case. Okay, so what we're going to do is we're going to come up with our 2 equations. And I see that non-members, so I'm going to put NM for non-members. They're going to pay $4 per class, or 4 times X. Members are going to pay a flat fee of $10, and then they have to pay $2 for every class that they take, or 2 times the number of classes. So this is my system. What I ultimately need to do is I need to find the break-even point so that I can determine which plan we should utilize. So we're looking to see how many classes we must take before we should consider paying for the monthly membership. And again, our equations were y equals 4x and y equals 10 plus 2x. So I'm going to go ahead and get my graph set up here real quick, and then we'll start plotting. So I'm going to start off by graphing the y equals 4x. So we start out at 0. We're going to go up 4 over 1, up 4 over 1, and I'm going to connect those points right now. Next, I'm going to graph the equation y equals 10 plus 2x. So I'm going to start out at 10, which will be right here. And here we're going to go up 2 over 1, up 2 over 1, and we're going to go ahead and I'm going to connect those points real quick. So now that I have my two graphs plotted, my point of intersection, as I can see right here, is going to be the coordinate point 5 and 20. So what that tells me is I have to take at least 5 classes. So 5 classes, which is going to be a price of $20. Okay, so I have to take at least 5 classes in order for the membership to pay itself off. So if I take 6 classes, I'm definitely making that I've got the better deal. But if I take anything less than 5 classes, so something like 3 classes, it's going to be better off for me to just do the pay per class. Because the 5 classes and the $20 fee, this is my break-even point. Please let me know if you have any questions. This does conclude our 7-1 video. I will see you guys in class. Have a great day.